And today we're going to be doing looking over two new Riemann sums. One is going to be the trapezoidal rule, and the other one is going to be the Simpson's rule. But first, let's look at this. So Galatians 2 says, "My old self has been crucified with Christ. It is no longer I who live, but Christ who lives in me." So what is that is saying to me is that Christ is filling up the area within you, so that when you walk, all that's gonna be embody you is Him, is Christ. So you can walk just like He walked. So exciting. So let's go to our calculus. So the problem with rectangular approximation methods is that they only depend on the area of rectangles. Though the midpoint RAM was generally more efficient, the area of a trapezoid can find the area under a curve more effectively. So as shown in this figure below, if the closed interval A to B is partitioned, so here's A, there's B, it's partitioned into subintervals. So yeah, partitioned into n subintervals. So all these are n. So that's 1, 2, 3, 4, 5, 6, 7. So we got n equals 7 here. Of equal length, h equals b minus a over n. So that would be b minus a over the number of subintervals. The graph of f on the closed interval a to b can be approximated by a straight line segment over each subinterval. So let's look at this. So what they're saying is, so each subinterval. So they start here and draw a straight line, and then here, straight line, and just like this, straight line. So all this is straight lines. So the trapezoid rule approximates short stretches of the curve y equals f of x with line segments. To approximate the integral of f from a to b, we add the signed areas of the trapezoids made by joining the ends of the segment to the x-axis. This is talking about that. The region between the curve and the x-axis is then approximated by the trapezoids, the area of each trapezoid being the length of its horizontal altitude times the average of its two vertical bases. So here's the trapezoidal rule down here. Okay? So you got h over 2. So this is kind of longer. So how I do this, I just kind of put the 1/2 here, and h, if you can remember, is b minus a over n. Okay? So you're going to multiply that. You're just going to get the y value of the first one. So if I was starting here, it would be the y value of this plus 2 times that y value plus 2 times that y value, and on and on and on until you get here, and that's going to be plus the ny value. So the first and the last are just the y value you see, and everything else in between is going to be multiplied. The y coordinate is going to be multiplied by 2 to get that. Okay, so let's get started on an example. So, yeah, the trapezoidal rule is also the equivalent to finding the numerical average of LRAM and RRAM. So if you were to do LRAM plus RRAM divided by 2, you will get the trapezoidal rule approximation. Okay, so that's all that means. So another way of confirming your answer. Okay, so here is an example. So I think we've done one like this before. Okay. So use the trapezoidal rule with n equals 4 to estimate the integral from 1 to 2 of x squared dx. Okay, another way you can confirm these is by doing the integration technique, which we learned in 5.3 and 5.4. However, you can use that to check. You can not use that to do the trapezoidal rule. So it says do the trapezoidal rule, do the trapezoidal rule. Okay, so let's look at this. So n equals 4. So we got 4 things here. Okay. So from 1 to 2, 1 to 4. So a way you could do that, you could do 1 divided by 4, so you're going into each fourth. Okay? Okay, and they give us our y values. How nice. So the first y value is, so from here to here is going to be 25 over 16. That's what that means. Okay, and this first one is going to be 1. I don't know. We'll see. Okay, let's go. Alrighty. Alright, so trapezoidal rule. So you're going to have T equals 1 over 2 times B minus A over N. So you have 1/2 times B minus A. So A is 1. So A is 1, B is 2. Times 2 minus 1 over N, which is 4. And then you're going to do F of 1 plus 2 times F of 5 over 4 plus 2 times F of 7 over 4, probably, no, 6 over 4. Plus 2 times 7 over 4. And the last one is going to be 2. Or you could do 8 over 4, which is 2. Okay. All right. So you're going to be putting everything here. So f of x equals x squared. Okay. So you're going to have, so we have 1/2 times 1/4 is 1 over 8 times f of 1. So f of 1 is going to be this number, which is just going to be 1. Yeah, 1. So f of 1 is 1 squared, which is 1. Plus 2, f of 5 over 4, which we see here is this number, 25 over 16. You could also put it right into here. So you could do 1 squared, 2 times 2 times 5 over 4 squared, plus 2 times 6 over 4 squared, or 3/2, plus 2 over 7 over 4 squared, plus 2 squared. 1 over 8, so that's going to be 1 plus 2 times 25 over 4 plus 2 is going to be 9 over 4 if you reduce that. 9 over 4. So this reduces 3/2. 3 squared is 9. 2 squared is 4. Plus 2, 49 over 4. Plus 4. And you're going to end up getting approximately 2.34. Okay? So what I'm going to want to see at least is this much in your work. It would help if, well, so the setup here, and then this, and then an answer. That is going to be what I'm going to be looking at in your work. Okay, let's do another example. So tables are actually easier because you get the y value right here. So an observer measures the outside temperature every hour from noon until midnight. So this is noon. That's going to be, we're probably going to make that 0. Okay. Recorded temperatures in the above table. What was the average temperature for a 12-hour period? Okay, so we're going to make h equal to 1. So trapezoidal rule. Oh, don't worry about this either. And go away. Okay, so we're going to be using the trapezoidal rule to get this number. So you got 1 over 2 times 12 minus 0 over 12 times f of 0 plus 2. Here's another way you could do. You could do multiply by 2. F of 1, F of 2, F of 3, F of 4, F of 5, F of 6, F of 7, F of 8, F of 9, F of 10, F of 11. So F1, if you don't feel like doing it, you can do this, plus f of 10 plus f of 11, close parentheses because you're done multiply by 2, and then multiply it by, or add a 12, f plus f of 12. That's 12. Okay, so that's going to be 1/2. Okay, f of 1, or f of 0, so f of 0 is 63 plus 2 times f of 1 is 65. You're just adding all these, 66, 68, 70, 69, 68, 68, 65, 64, 62, 58, plus 55. And your answer is going to be 782. Okay, but to find the average, so the average of f is going to be 1 over b minus a times the trapezoidal rule that we got, and then it's going to be equal to 1 over 12 minus 0 times 782, which is going to be 65.17 degrees. Okay, so find the trapezoidal rule, get the area first, and then multiply 1 over b minus a times the area under there. And that's how you get your degrees. Okay, last algorithm is going to be Simpson's rule. So we're going to approximate, so Simpson's rule is going to be 1 over 3, or h over 3, which is b minus a over n times 1/3. So this is different. So the first and the last are by themselves, and then everything in between alternates 4 and 2, 4 and 2, 4 and 2, 4 and 2. Okay, so let's go ahead and do this. So we got 1 to 2. So we're going to be going in the n equals 4 units. So you got 2 over 4, which is 1/2. So everything's going to be in like 0.5s. Okay, so let me draw a graph over here. 1, 2. Here's 1. There's 4. Okay, drawing 4 rectangles. So to do that, you're going to go 2 divided by 4, which is 0.5, or you could do this, but it's not always going to be that easy. Okay, so you're going in 0.5s. Alright, so Simpson's rule, 1 over 3 times b minus a. So you have 2 minus 0 divided by n, which is 4, times f 0.5 plus 4 f of 1 plus 2 f of 1.5 plus 4 f of 2. Oh, sorry, that's gone, because that's the last one. You don't multiply anything by that. So then you have 2 over 12, or 1 over 6, times, I forgot to start at 0. Oopsie, so that's wrong. 1/3 times 2 minus 0 over 4, that's fine. You were supposed to start at 0. F of 0 plus 4 f of 0.5 plus 2 f of 1 plus 4 f of 1.5 plus f2. Okay, so we're going to have 2 over 12, or 1 over 6, f of 0 is 0. 4 is 0.3125. Then you got 2, f of 1, which is 1. Or f of 1 is going to be 5. Okay, so 5 times 1 to the 4th is 5. Plus 4, f of 1.5, so 5 times 1.5 to the 4th is going to be 25.31. Plus, and then f of 2 is going to be 5 times 2 to the 4th, which is 80. And your answer is going to be 385 over 12. Okay, so that's the area of the curve. Now in this next one, we're going to do a table, which you can also do. So another way you could do this, oops, let's see. So another way you could have done that one, y equals 5x to the 4th. Okay, go to window, or you could do probably a table set would probably be better. Table set, you could start 0.5, and then we could go look at the table. Okay, so that's another way you could do that. I think I put it in wrong. Yeah, I did. 5x up 4th. Okay, so table. Okay, and that's how you get that. So we're going to do the next one kind of like that too. So the next one isn't going to be as easy as we've been seeing, because unlike this, so you got 0 to 2, okay, 2 intervals, I can easily make that into 4. Okay, so the reason why I've been doing this, if you did 2 divided by 4, you would get 0.5, so you kind of go in a sequence of 0.5. So for this one, we're going 0 to 3 and n equals 10. Now if this was 9, n equals 9, it would be easy because we have 3 units, but we do not. So we're going to make a table. Well, first we're going to see what our distance is. So to see where each of our n is, we're going to do 3 divided by 10 to kind of see the difference in between. And 3 divided by 10 is 0.3. Okay, so we're starting at 0. The next one's going to be 0.3. Next one's going to be 0.6. 1.2. 1.5. 1.8. 2.1. 2.4. 2.7 and 3. Okay. Our f of x, okay, so quickly I'm going to put that in my y equals. So we're going to have the square root of x plus 1. Okay. Second table, I'm going to be going to 0.3s. So you got second window. Now I'm going to go to second table right here. Okay? So you see all your numbers. So we got 1.14, or 0, yeah, 1. 1.14, 0.6 is 1.269, 1.26. Next one is going to be 1.38, 1.48, 1.58, 1.67, 1.76, 1.84, and 2. Okay, so we're going to actually be comparing LRAM, trapezoidal, and Simpson. So LRAM, I'm going to do down here so we have room. So LRAM. So LRAM is B minus A over N times the first point you're going to use is the furthest to the left x value, which is going to be here. So you're going to include all these values except for the last one. Okay? All right, so LRAM, if you can remember, is b minus a over n. So you got 3 minus 0 over 10 times f of 0 plus f of 0.3 plus f of 0.6 plus f of 1.2 plus f of 1.5 plus f of 1.8 plus f of 2.1 plus f of 2.4 plus, I'm trying to make it so you can see when I'm doing better, f of 2.7. Okay, that's left endpoint. So that's going to be equal to 3 over 10. F is 0. So now you're finding the table. So you're going to do 1 plus all of these. 1 plus 1.14 plus 1.26 plus 1.38 plus 1.48 plus 1.58 plus 1.67 plus 1.76 plus 1.84. Okay, so that's everything, f 2.7, and your answer is going to be approximately 4.509. Okay, trapezoidal rule. So this is 1/2 times b minus a over n. So you got 1/2 times b minus a over n. So that's going to n is 10. Okay, so trapezoidal rule is when you are, the first and the last is just f of x, and then in between everything's multiplied by 2. So you're using all of these numbers. So you got f of 0 plus, now if you want to, you could do 2 times f of 0.3 plus f of 0.6 plus f of 1.2 plus f of 1.5 plus f of 1.8 plus f of 2.1 plus f of 2.4 plus f of 2.7. Okay, so that's going to end everything being multiplied by 2 plus f of 3, and then close your parentheses. So you're going to have 3 over 20 3 over 20 times f of 0 is 1. 1 plus 2 times all of these numbers except for 2. 1.14, 26, 1.38, 1.48, 1.58, 1.68, 1.67, 1.76 plus 1.84, close parentheses because that's where it stops with multiplying by 2, and then add 2. Okay, f of 3 is 2. And you get 4.659. Okay, so you're seeing everything I'm doing is the work that I'm going to be wanting to see on your examinations. Simpson's rule. Okay, so that's 1 over 3 times b minus a over n. So f of 0 plus, I think you start with 4. 4 f of 0.3 plus 2 f of 0.6 plus 4 f of 1.2. Did I missed the number? There's supposed to be a 0.9 here. 0.9, and that's supposed to be 0.9 is supposed to be 1.38. 1.48, 1.58, 6, 7, 8, 4, and 2.7 is supposed to be 1.92. Okay. To give you a better look, I'm going to show you this one. Okay, so this is what the table should look like right there. Okay. Alrighty. So 4 of, I just noticed that because everything's 369.9 plus 2f of 1.2 plus 4f of 1.5 plus 2f of 1.8 plus 4f of 2.1 plus 2f of 2.4 plus 4f of 2.7 plus f of 3. So you get 1 over 10, 1 plus 4 times 1.14 plus 2, 1.26 plus 4, 1.38 plus 2, 1.48 plus 4, 1.58 plus 2, 1.67 plus 4, you're just alternating 2 and 4, 1.76 plus 2, 1.84 plus 4, 1.92, and lastly plus 2, and you will get 4.662. So the actual area of this is 4.667. Okay? So if you could see in integrals and stuff like that, Simpson's rule is going to more directly align with the definite integral between all of them. So that concludes our lesson on trapezoidal and Simpson's rule. If you have any questions, please let me know before, yes, just please let me know. Okay? All right. Have a great weekend. Goodbye.